Hello, you're welcome to my YouTube channel and welcome to Learning Coordinate Geometry 2.0. Yes, this is the second video in the two-part series on coordinate geometry. Now, we need to read our first question. The point P has coordinates 10, 12 and point Q has coordinates 2, -4. Find the coordinates of the midpoint of line PQ. Please note, before you attempt to answer any question under coordinate geometry and you are given a pair of coordinates as this, please ensure that you label your coordinate pairs. What do I mean? This is the first batch here. The first batch of coordinates I have are 10, 12. So I'm going to label this x1 and this y1. This is the second batch I have here. So this will be x2, y2. Why do we need to do this? This is because most of the things will be asked to calculate. We need to identify what our x1 is or what our x2 is. You would understand better pretty soon. Please stay with me. Now, to find the midpoint of any line, we need to do this. Like we're looking for the average of each pair of coordinates. So it's going to be x1 plus x2 over 2, comma, y1 plus y2 over 2. You can now see why it's important for us to identify our x1 and x2, y1 and y2. So let's just substitute these values in here. So it's going to be 10 plus 2 over 2, comma, 12 plus -4 over 2. This is going to give us 12 over 2. 12 plus -4 is actually 12 minus 4, and that's going to give us 8 over 2. And this invariably, this becomes 6, 4. So our final answer here is 6, 4. All right, so the next question. The gradient of line PQ. The formula for finding gradient of any line is given as m equals to y2 minus y1 over x2 minus x1. Gradient is given as the rise over the run. So let's substitute our values again. Our y2 is -4 minus y1, which is 12, over x2 is 2 and our x1 is 10. So that is 2 minus 10. And this would give us -4 minus 12 is -16 divided by 2 minus 10 is -8. The minuses cancel out. 16 divided by 8 will give us 2. So the gradient of line PQ is 2. Now we've been asked to find the equation of a line perpendicular to PQ that passes through the point 2, 3. Please note that when two lines are perpendicular, it means that one line intersects the other at right angles. So there is a 90-degree angle between the two lines, saying this is line 1 and this is line 2. All right. So if we are being told that the line is perpendicular to PQ, so we are assuming that PQ is our line 1 and the new line will be line 2. Algebraically, we know that for perpendicular lines, the product of their gradients is equal to -1. It means that the gradient of the second one will be the negative reciprocal of the first one. All right, so we need to find the gradient of PQ. We know the gradient of PQ already, it's 2. So the gradient of the new line, which is our M2, will be given as -1 over 2. That's been sorted. Now remember that the general equation of any line is y equals to mx plus c, where m is the gradient and c is the y-intercept. So the only thing left here for us to find is our c, since we just found our m. How do we handle that? We are going to substitute this pair of x and y into this y equal to mx plus c. I hope you understand that. Okay, so our y is 3 equals to what's our m minus 1 over 2. Our x is 2 plus c. So this is going to be, this 2 is cancelling this 2. So we have 3 equals to minus 1 plus c, and 3 plus 1, because when the minus 1 crosses over, it becomes positive, equals to c. So that means our c is 4. So we're going to put all of this together, knowing now our gradient being minus 1 over 2. So the equation of the line that is perpendicular to PQ will be y equal to minus x over 2, since the gradient is minus 1 over 2, plus 4. All right. Now we have a new question here, a different set of coordinates. Fine, they are still P and Q, but they are different numbers. Observe that here we had 10, 12 and 2, minus 4, but here we have minus 3, 8 and 9 minus 2. So we need to start over and do the same thing. First step, label your coordinate pairs. This is the first one here, so this will be x1 and this will be y1. This is the second pair, so this will be x2 and this is y2. Now, in this question, we have been asked to calculate the length of PQ. Now, the formula for finding the length of a line is given as the square root of x2 minus x1 all square plus y2 minus y1 all square. All right, so this is, we just plug in our values again. X2 being 9, x1 being minus 3. So this is minus of minus 3. Please be careful when you substitute it. Plus, what is our y2? Minus 2. And our y1 is 8. So that is minus 8 here. And this leads to the square root of 9 minus minus 3 is actually 12 square, plus minus 2 minus 8 is minus 10 square. The square of 12 is 144, whereas the square of minus 10 is 100. Adding those two together, we have 244. So our exact answer here is the square root of 244. Now, if this is a non-calculator paper, this answer will be perfect. You just leave it as it is. But if it isn't if it's on the calculator paper, you need to evaluate the exact value of this, or you need to evaluate this and put it to the required degree of accuracy. This is what I mean. You find out the square root of 244 on your calculator, and it's going to give you 15.6204 and so on. Since we are required to give our answer to 3 significant figures, so here will be 15.6. Oh, I made a mistake there. It's 15. 15.6. All right. So we're done with the A part of this question. Now to the B part of this question. Find the equation of the line parallel to PQ. Now, when two lines are parallel, their gradients are same. So whatever the gradient of PQ is, it will be the same as the gradient of this new line. But wait, we haven't even calculated the gradient of PQ. So that's the first thing we need to do. So gradient is given by m equal to y2 minus y1 over x2 minus x1. If you check our value of y2 and y1, y2 is minus 2, y1 is 8. So we have minus 2 minus 8 over the values of our x2 are 9, and the value of our x1 is minus 3. So we are going to have 9 minus 3. Right. So evaluating this, the numerator becomes minus 10 over 9 minus 3 is 12. So minus 10 over 12, we take this to the lowest term. This 2 can go here, it gives us 5. 2 here, it gives us 6. So our gradient is minus 5 over 6. Now that we know the gradient, we just use this pair of coordinates and plug it into our general equation of a straight line, which reads y equal to mx plus c. Our y is minus 1 equal to our m, which we just found, minus 5 over 6 multiplied by our x, which is 6, plus c. Minus 1 equals to this, we'll cancel this, minus 5 plus c. So minus 1, the minus 5 crossing over becomes plus 5 equals to c. Minus 1 plus 5 is 4. So our c is 4. Putting all the details together with our m being minus 5 over 6 and our c being 4, we have our equation as y equal to minus 5x over 6 plus 4. And finally, we've been asked to find the equation of the perpendicular bisector of PQ. What is a perpendicular bisector? We know what a perpendicular is. It means the two lines are cutting each other at 90 degrees. But for a perpendicular bisector, it means that the other line is passing through the center of the original line. So we need to go back and find the midpoint of PQ, because that is where our perpendicular bisector will pass through. So the midpoint of PQ, remember, midpoint is given by x1 plus x2 over 2, comma, y1 plus y2 over 2. All right, so substituting our values, our x1 is minus 3, our x2 is 9 divided by 2, comma, our y1 is minus 8, and our y1 is 8. Y1 is 8. And y2 is minus 2 over 2. So minus 3 plus 9, that is 6 over 2 here. And 8 minus 2 is also 6 over 2. So it means our midpoint is 3, 3. Now we know where the line is going to pass through. It's going to pass through 3, 3. Now we need to find the gradient of the perpendicular bisector. Remember, when two lines are perpendicular, the relationship between their gradient is given by m2 is minus 1 over m1. So our m2 here will be given as minus 1 divided by our m1, which is minus 5 over 6. This gives us minus 1 times minus 6 over 5. Remember, you need to flip it when you're changing your division sign to multiplication. And this results in 6 over 5. Beautiful. So we have our gradient and we have the point the line is going to pass through. All we need now is to find our C. Our C will be calculated by y equals to mx plus c. Our y is 3 equals to, our gradient is 6 over 5 times 3 plus c. So this is 3 equals to 18 over 5 plus c. and that is 3 minus 18 over 5 equals to C. Note that 3 is actually also 15 over 5. So this will result in minus 3 over 5 equals to C. Putting it all together, it becomes y equals the gradient being 6 over 5x plus the y-intercept being minus 3 over 5. So we have come to the end of this coordinate geometry 2.0. We have tried to look through all the possible scenarios of questions you could be asked on coordinate geometry. I hope you have learned a thing or two. If you have questions, please leave them in the comment section. Thank you for watching and see you in the next one. But wait, have you subscribed yet? Please do, and share with your friends. Thank you. See you in the next one.